Okay, looking at finding an inverse function. So basically, if y equals f of x, and you want to find the inverse function f of minus x, the steps that you do, first of all, it has to be 1-to-1 in order for it to even work, otherwise it's not even going to be a function. So for every x, there needs to be 1y. So this means that it will pass, it's a function that will pass the horizontal line test. So what we mean by that, if you had this here, this does not pass the horizontal line test, nor does like a parabola, because for every x, sometimes we have two y values. For that y, you actually have two x values. So f of x needs to be a function that actually passes the horizontal line test, and that's what makes it 1-to-1. Something that is a 1-to-1 function looks like this. That's 1-to-1, because if you put a line through it, see it's a function, that's why it passes the vertical line test, but also passes the horizontal line test. So every x or y, there is only one, every x is one y, and for every y there's one x. Okay, so once you establish that an inverse does exist, okay, and an inverse will exist if it passes the horizontal line test. Now you can check something passes the horizontal line test by sketching and then putting a line through it and just stating that it passes the horizontal line test. You could also check that it's always increasing or decreasing. And in order to check where something's always increasing or decreasing, you can look at its gradient. So you can see that the gradient is always greater than 0, but the gradient can also equal 0, so that's okay as long, you can have one stationary point, but as long as it's only increasing or only decreasing. So it could be that and y dash is 0. So this or this, not together. Okay. So you can check it passes the horizontal line to see if it's only increasing or decreasing. Check if it's 1-to-1. So for every x, there is only one y value, and for every y, there's only one x value. So to actually find the inverse function, so you've got y equals f of x. The steps are, what you do is you swap the x and the y, and then you make y the subject. So for example, if you've got y equals x cubed minus 8, then to find the inverse, x equals y cubed minus 8, x plus 8 is y cubed, and then you simply just cube root the other side. So that would be your inverse function. Now if you were looking at this and sketching it, there's y equals x cubed. To find out where the inverse of that is, if you draw the line y equals x and you reflect it, then you actually get the inverse function. Okay, so the inverse function of that would be the cube root of x. Now for this particular function that we're looking at here, I'm just going to draw it up and I'll show you that when you flip that in the line y equals x, you'll get the inverse. So that's minus 8 here. So it's a cubic that looks like that. It'll go through 2 and look like that. So if you were to draw the line y equals x, so at this point here, that is where the two things will intersect, because that's where you flip it over. So that'll go like that. This point here, which is 0 minus 8, will go to minus 8, 0. So where's minus 8, 0? Well, that's down there. So that's going to be that point. This is going to come through here, because you know that they intersect on the line y equals x. And then that's going to come back down here like a cubic. and that would be the reflection of that line. So if you have, say we have y equals root x minus 1, and you wanted to find, first of all what we'll do is we'll find the domain and range of that, and then we'll find the inverse. Okay, so that one would be 1 to the right, and y equals root x is a parabola on its side like that. So it's actually going to look like that. Its domain would be x minus 1 has to be greater than or equal to 0, because what's under there has to be positive, so x is greater than or equal to 1, and the range is y is greater than or equal to 0. And you can also see that from the graph. Now if we draw the line y equals x, and we reflect this, so this point here is 1, 0, that will go to 0, 1. So 0, 1's there, and if you reflect it, it's just going to look like that. So to actually find its equation, swap the x's and the y's. So you get x squared is y minus 1, and y is x squared plus 1. But do you notice it's only half of the parabola? Because the domain was restricted here, because it had to be a function, it's got a square root on it. So the domain and range of this inverse, so the domain of this inverse would be x is greater than or equal to 0, and the range is y is greater than or equal to 1. Because like there's the 1 there, so it's greater than or equal to 1. Do you notice that they're opposite? So the domain of the original function, x is greater than or equal to 1, but of the final function, y is greater than or equal to 1, so they swap. The domain of the original is y is greater than or equal to 0. That becomes the range, of the original is y is greater than or equal to 0. That becomes the domain of the inverse, so they swap. So the domain and range will swap. So the domain of this will become the range of that. So if that was f of x and that was f of minus x, and this one swaps with that one.